Now, welcome back. Let's start by dealing with the types of relations, right? We have looked at the introductory video giving an overview of what relations are, the mappings are, and the functions are. Now, let's go in depth, zooming on the types of relations, right? So, the relations basically deals with the connection between two sets of numbers or variables or whatever. So we have one set, for example, in a set like this one, which we call what, set X. Now this set X contains what, variables or numbers or figures or digits. Now we have another set, the second set, which is what we call it as Y. So the Y also has elements. Example is what, Y. So big Y and a small y's. Now the first set, we have a special name that we call it by something we call domain. And then that's a container. So domain is a container. And then the codomain is another container for the Y sets, right? So a domain, the element of X, and then a codomain, the element of Y. So we can also give it another name as the X being the inputs, and then the Y, the outputs, right? So that is it. So we have domain and codomain. Now I'll be switching or interchanging these names instead of talking a lot. So I'm going to refer to the technicalities, right? So the domain and then the codomain. Now, under these, we have the sets or the numbers in them and that. So going into the sets, the elements in them, this is where we talk about what? The types of what? The relations. Now, I will come back to something we call image after I zoom into the types. So stay tuned. Now, for the purposes of easier understanding, I am not going to go according to the types that the book listed. The book is saying many to many relation, then one to many, and then many to one, and then one to one. But I'm going to start with the simplest one, starting with what? The one to one. You understand? The one to one. That will build a foundation. So the one to one, we are saying that here one element in the domain is connected to one unique element in the codomain, and no two different elements share the same image. Now, the image that I was talking about, the image means that all the elements here must be connected to something in the domain. All elements in the codomain must be connected here. So if any element is here but has no connection to any of the elements here, that element is not part of the range. So for a range here, we are saying that the range of this codomain is 3, 6, 9. Now the range only comes from the codomain. One thing, the range only comes from the codomain. So that is 3, 6, 9. If there were any other elements like 5 has no connection in here. So that is not part of the range. So the range is actually a subset of the codomain, if only it's connected. If it has no connection, it's not part of the range. But all the elements in here are called the codomain. All elements, whether connected or not, is part of the codomain. But if you are connected only, we can have a subset. So don't worry, if you see an example where a number or element here is not connected to here, and that is not part of the range. So that is the difference between the codomain and then the range. So the element, the one-to-one, one-is-to-one relation is saying that one element in the codomain, is connected to one unique element in the codomain, right? One element in the domain is connected to one unique element in the codomain, and no two different elements, right, share the same image. So what it means is that you can see that 3 has only one connection, 6 has only one connection, 9 has only one connection. So it means that 3 is not having two connections. Let's say from 1 and also having from 2. It's only mapped to 1 and 1 alone. So it's 1 is 1. So arrow is straight. If there were another connection from here to here, that means this image is having two inputs, and that will be they violate the rule of 1:1. So that is it. Now let's go to many to one. Many to one. So many to one, that is it. So many to one is saying that two or more elements in the domain can map to the same elements. Two or more elements in the domain can map to what? The same elements in the codomain, right? So let's say, for instance, we have 15 here, and then we have 45. They are all mapping to what? 5. So many. This one is 1, this one is 1. So many from here are connecting to one element in the what? In the codomain. It's as simple as that. Now let's move to one to many. One to many. This is it. And one to many is saying that one element in the domain is connected to more than one element in the codomain. So here it's connected to this, it's connected to this, right? 3 is connected to 9. At the same time, 3 is connected to what? 18, connected to 27, right? So one element in the codomain is connected to more than one element in the codomain. That is it. It's as simple as that. It's connected to here, connected here, connected here. Now there's a trick between this and then the many to many. Now let's go to many to many. Many to many is saying that many elements, this is one element, this is another element. So there are many here. This many elements. We are saying that many elements in the domain are connected to many elements in the codomain. So many connected to many. So look here. 6 is connected to this, connected to 3, connected to 5 here. Now 7 again is connected to 2, connected to 3, and connected to what? 5. So many here, connected to many. Many here, connected to many. Right. Now look at the distinction between these two. In the many to many, this one is connecting here, connecting here, connecting here. Right? Coming to here. But when you look at one to many, this one is connected to what? Individual element, and these are not connected by this. So here there's no overlap. But here, there can be overlap, right? So 6 connected to 2, connected to 3, and it's coming to what? 5, which is connected by 7. So that's one trick. So there's an overlap. But here, there is no overlap. When it comes to this one to many, 1, 3 is here, individual, connected to 9, 18, 27. And it's not connected to what? 16 here, or 8 here. But 4 is connected to 8, connected to 16. So 1 to many. So 1 is connected to many, right? 1 is connected to many, right? Here, many is connected to what? Many. This, and that. 7 also connected here, connected here, connected here. So that's a bit tricky, right? But that's the whole idea. This is more like a visual understanding, visual grasping, right? So the important conclusion that we can draw is that so among these 4, the types of 4, 1 to 1 is a function, and the many to 1 is a function. We looked at this in the introductory video, right? So 1 to 1 is a function, many to 1 is a function, 1 to many is not, and then many to many is not. So when you get to function, we'll talk about this clearly, right? So let me give you some real life situations. I think we can take this along. Now, 1 to 1 example is a student have one index number. Every student one index number. And then many to 1 students coming from a hometown. So many students coming from a hometown. So that's many to 1. Now, 1 to many example is one parent having number of children. That is it. And then many to many is students studying subjects. So you get a point. So that is it. I think when you go on to do with calculations and all that, you understand it better. So we will see you in the next video. We will deal with calculations. Stay tuned, watch, like, share, subscribe. See you soon. Bye for now.